Okay, so our first and last section for this week is 3.3. Okay. A lot of the stuff we do in 3.3, it's stuff you've already done. It's just written differently. That's all. All right, so we've talked about linear functions. Does anybody remember how we write a linear function? Starts out like, why don't I even say anything? Yep. Y equals mx plus b. All right, so, Xander, what's up? That's the first thing. Yep. So that's called y equals notation, or whatever you want to call it. Point slope form is another name for it. Okay. But another notation we can use that means exactly the same thing is called function notation. In function notation, the m, the x, the b all stays the same. The only thing we're going to change is y. We don't use the letter y in function notation. We use something that means the same thing, but it's written a little differently. What's in that box, that's called function notation. Okay, so what you want to put in that box is f, and then in parentheses x, I'll tell you how you pronounce it in a second, equals mx plus b. This part right here, the way you pronounce it, f of x. So what that means is what you're going to write after the equal sign is a function using x.
Guys, remember going to make you write it out, say f of x, like parentheses or up there in quotes. Remember going to make you write it out. We're just explaining to you what it means.
Okay, so how do you pronounce that again? F in parentheses x?
F of x.
F of x. Yep. F of x. And the F and the X, sometimes they're different letters. We might have Y. We might have that. How would you pronounce
G of H.
G of H? Okay, whatever the letters are, G, letter of letter. F of X. Okay, whatever the letters are. Now, the letter that you put in the front, okay, that's the name of the function. Okay, function F, function G. So if I wrote on the board a couple things.
Function K.
Now I have three functions on the board.
What's the first one?
And I could tell you guys, look at function K, right? That would be the 3x plus 4. Or I could say, like, what do you get if you plug in 1 into function P? Okay? All these letters do is give us, they give us a name. They give us a name to call the function. If they were all y, like y equals 3x plus 4, y equals 2x minus 5, they're all y equals. So I wouldn't be able to give them names. This gives them names. Okay? So the top one would be called function K, function G, function P, or like the one we have here, function F. Okay?
Nice.
So when you see this symbol, and we just kind of mentioned this, F and then the parentheses means the function. So you pronounce it F of whatever's in parentheses. Okay, you guys just did that with the other three. So I'm not going to fill in a specific letter because it could be anything. It's just the function of whatever letter you have here. Most of the time it's an X. I would say like 9 times out of 10 it's going to be an X. But the letter in front, K, G, P, that could be anything.
Should we put an X in those parentheses?
No. So, all that we really did was change y to f of x. That's all we did on paper. We're just not writing a y anymore. We're putting f of x. F of x still means y. Okay, just a different way to write it. You guys did this in the warm-up. Evaluate. Somebody tell me what evaluate means.
Find the answer.
Yep, Sophia?
To plug in like whatever, if it says at the top, it says evaluate like y equals 40, and then you plug in 40 to the y in the equation.
Yep. So evaluate, they're going to give you a number, they're going to give you a letter, you're going to plug in whatever they give you for that letter and simplify. A lot of times with evaluate, you get a number. So I would say most evaluate questions, you're looking for an answer, that's a number. Okay, so we're going to practice doing some evaluating. I'm going to give you guys a function, and I'll give you 3 different numbers to plug into it. Okay, does everybody have what evaluate means? Good? All right. Can somebody read what I just underlined? How do you pronounce that, Will?
F, X.
One word you forgot in the middle. Will, you think you got it? No? Noah?
F of X equals negative 4x plus 7.
Yes, f of x equals negative 4x plus 7.
I was going to say that.
Who can tell me
You're supposed to be saying, oh.
what's the name of the function here? Single letter. This is function f. So if I said look at function f, that means look at negative 4x plus 7. All right, so it says evaluate for negative 3, 0, and 2. So what am I going to do with the negative? Let's start with negative 3. Joe?
Well, negative 3, when you plug it into
What are you plugging it in for?
for the x.
You're plugging it in for the x in function f. Exactly. So f of negative 3. Okay. I'm going to do the calculation out on the left. If you want to put all the answers in one spot nice on the right, you can. Means change all your x's to, what are we plugging in?
Negative 3.
Negative 3. And now just do out your arithmetic. What's negative 4 times negative 3?
Positive 12.
12?
Plus 7 is 19.
12 plus 7
19.
is 19.
I did it.
Yay.
So what this means is the value of function f, if you plug in negative 3 for x, is 19. That's what that means.
Interesting.
The value of function f at negative 3 is 19. Another way to say it is if you plug in negative 3 for x, you get 19 for, what letter does that represent again? That f of x? Taking the place of, what's it taking the place of?
Variable.
No.
Oh, wait.
What letter? No, what letter did we use before?
X. Oh, wait.
G. A. Y.
F.
Y, right?
We did?
4.
Yeah. Remember? We said all we did was change y to f of x. Okay, it's another way to write the letter y. So if I asked you here, if you plug in negative 3 for the x, you get 19 for the y. Or you could say you get 19 for f of x, which is y. Right, let's do 0.
I got 7.
Somebody give me my equation I would set up to find f of 0. Yep, go ahead, Sydney.
Negative 4 and then parentheses 0.
Perfect. Yep. Like it. Negative 4 times 0, that's just 0. So what's the value of the function when x is 0?
0 plus 7, so it'd be 7.
7. Yeah. All right. And now we have one more. Find the value of the function when x is 2. Okay. Or tell me the y value if you plug in 2 for x. Just give me my equation first. Yep.
Negative 4x, parentheses 2.
So negative 4, no x. Just negative 4 times 2. Yep.
And then, wait.
Plus,
Oh yeah, plus 7.
plus 7.
And then it's negative 8 plus 7.
And negative 8 plus 7?
Yeah.
What's the answer to that?
Oh wait, negative 1.
Good. Very good. Nice job. So this last one says the value of the function, if you plug in 2 for x, is negative 1. Okay. Any question on that? How did we write an x and a y value before? Like now we're kind of making like this little table here. What's another way you can write an x value with a y value? Yeah?
As a coordinate?
As a coordinate. So another way to write your answer is like that. If x is negative 3, y is 19. If x is 0, y is 7. If x is 2, y is negative 1. Okay? So what we're doing now isn't really that different than what we've done before. It's just a different way to write it.
Yeah.
Yeah. All right, steps in solving an equation. Can somebody remind me of the first step?
You guys, for that, but what Mr. Hager just did, when you're plugging in for x, you're gonna have 2 steps. If there's a number next to the x, you have to multiply, then add or subtract. There's no moving anything around. When you're solving for x, there's no moving anything around. Just do the math. You don't have to like add 3 on one side, add 3 on the other side. Just do the math when you're solving for x.
Okay, so these steps, guys, we've already done this, so you don't have to write it again.
Yay!
What's your first step when solving an equation?
Combined like terms.
Simplify, which under simplify, there's 2 things. That's one of them.
Combine like
Yep, we haven't got to example 2 yet. Example 2 is on the next page.
It's a little different. Actually.
What's the first thing you do under simplify?
combine like
That's the second thing.
Oh.
One more. There's a property that we have to use sometimes with parentheses.
Distributive property?
Distributive property. Okay, so first step, simplify. What's the step after simplify? What do you do next?
Combine. Oh.
Solve the problem.
Doing what operations?
Addition or subtraction.
Good. Addition or subtraction. Last 2 things.
Multiplication and division.
Multiplication and division. Okay, so that's just a reminder of our steps. S-A-M. Great. So now let's use those steps to figure out this. Okay. First of all, how do you pronounce that?
Oh.
Actually, you know what? Just even start with that part. Joe?
H of X.
H of X.
Equals.
So this tells me that whatever's under that equal sign, it tells me what the variable is going to be. There's going to be an X. Okay? That's what it tells you. And if you look, sure enough, there's an X. So H of X equals 2/3 X minus 5. That's my equation.
Yeah.
I forget.
And this is a little different than the last one. This is not an evaluate. This is more like solve. What's different about what they're giving me this time? Anyone see what's different about what they're giving me?
They're giving you like a
equal, you have to multiply.
Okay, so the equation has a fraction in it, but this is what they're giving me in terms of what I'm going to use to solve the problem.
Oh, they're saying h of x equals something, not x equals.
Exactly. Good job. They're saying h of x equals something, not x equals. So where is this -7 going to go?
Where h of x would be.
Where h of x would be, not x. That's going to go right there. So be very careful where you plug in the number. Are you plugging it in for x, like we did in the first problem? Or are you plugging it in for h of x? So on the left, you've got -7. Is anything going to change on the right now?
No. Yes. What if the x changed to a -7? No.
Are we plugging in -7 for x?
No.
No,
Sorry.
h of x. Oh, that's all right. Great, so now we need to solve that equation for x. Okay, I'm going to show you guys a trick, because how many people like to deal with fractions?
No.
Well,
Just trying to
I like math, so.
I mean, I can't stand math in general, I'm not good
I
at it, but
would
fractions
either
are
turn
even worse than
the
math.
fraction
Yes,
into
no,
a decimal.
Or even decimals. I want to, okay,
Or I'd put the whole number over 1.
what we're going to try to do is get rid of the fraction. What's making that, what's the fraction in that problem?
2/3.
2/3, right? What's the denominator? 3. So if we take and multiply everything by 3, okay? We've kind of done this before, like when we solve inequalities and we have to divide everything by the same number or multiply everything by the same number.
Are there going to be fractions on the test?
Yeah, could be.
Where's my pencil?
Let's look at what happens if we multiply everything by 3. What's -7 times 3?
21.
-21.
I have a question.
Yes, Joe?
Why are we doing it like that, not just adding fractions?
I'm just showing you a different way to avoid fractions.
Oh, okay.
All right, so when I'm done, I'm not going to have any fractions in this problem.
Okay.
Now, we have 2/3 times 3.
Where did we get the 3 from?
You're multiplying everything times 3.
Multiplying everything times 3.
Why is it 3 though?
Because 3 is the denominator.
We just totally did it.
Just watch what happens. Just watch. Don't ask any questions. Watch what happens.
You have to.
Okay? When I say watch, I mean me, nobody else. We're going to multiply everything by 3. -7 times 3 is -21. What about 2/3 times 3? What's 2 times 3?
Oh, it cancels out.
6? What's 3 times 1?
3.
Become a
3?
Well, why didn't you just do
What's 6 divided by 3?
2.
You could have just canceled
Oh,
everything.
I'm
into
so
2.
smart.
Yep, there's always multiple ways to do things in math.
Oh, I was going to say you didn't even have to multiply.
Cross canceling would be
And
much easier.
and
Yeah, just cross out the
what's with the 2? 2
2.
2x.
x
So it'd be
minus,
-5.
careful, -5 times 3.
15.
15.
Then you add 15 to both.
Now we're going to solve. So
Oh boy.
when I have a problem in math that I have to solve that has fractions in it, that's the first thing that I do. I get rid of fractions so I don't have to think in my head, how do I deal with the fractions? And if you triple everything in this problem, it automatically gets rid of your fractions because it reduces. If you don't want to get rid of fractions that way, you don't have to. Solve it with fractions. You're going to get the same answer. Totally up to you. All right. Now,
Wait, what?
guys,
I don't understand that.
then don't do it. You don't have to do it. Just solve it with fractions.
Wait, what was it? If that was the...
Now,
That was...
what would I do from here?
Say it.
What would I do from here?
Minus 15 from both sides.
We already have a minus 15.
Yeah.
You would add 15. Yep. -15 plus 15.
Is this gonna be on the test?
Yes.
So like a problem like that.
I'm not gonna teach you anything that's gonna be not on the test.
Wait, like a problem like that's what's on the test?
Yes.
Well, yeah, can you?
Guys, we're
stop it?
just solving an equation. If you don't wanna solve
We
it,
only have 1 day to go over.
yeah, but we've been solving fractions since September. If you don't wanna deal with the fraction, if you don't like doing it this way, just deal with the fractions. You're gonna have to multiply by reciprocals and all that stuff.
I don't know how to do any of that.
Well,
I can learn this way, but it's not like.
yeah, if you don't remember the reciprocals and all that, then you gotta learn this way.
Yeah.
Okay? And we don't have time to go back over how to solve equations. That was chapter 3 stuff. All right, what's negative 21 plus 15?
You subtract 6, and it is a higher.
The negative is higher, so we're going to get a negative
6. And then you subtract.
6.
I said that.
It's because you're the second.
And now, what's my last step? Gemini?
You would divide 2 on this side.
Divide both sides by 2.
And then you get negative x. So we just
And we get x equals
negative 3.
You started.
negative 3. Guys, you really need to pay attention. All right? If I can't control you, you're going to have to leave. I'd rather not do that. So what's the issue here? I know.
I don't know why we're confused.
It's very frustrating when someone's trying to explain something to you. Okay? All right. Since people don't seem to like that method, we're going to go back and solve it again the way we've solved it all year. But now I'm going to have to use reciprocals and all that stuff.
That makes
I like that method.
All right, well, let's look at it that way. Let's take the same problem again. 2/3 x minus 5. Hey, what would be my first step to solving that one?
You flip a fraction. Did you flip it?
Nope, don't flip anything yet.
What do you want to get by itself in that problem?
Oh, yeah.
X.
Yeah.
So what are the steps? We simplify, there's no simplify. What's after simplify? Add or subtract, and in this case, what did you say, Gemini?
We're adding 5.
We're gonna add 5. Here, here. What's negative 7 plus 5? Negative 2. But now you've got to figure out a way to deal with that fraction.
Yeah, oh, what is?
And this is where sometimes people get confused. Yep.
You have to get x like so, so you do the reciprocal.
Yep. What do you do with the reciprocal? Okay. Close, not divide by the reciprocal.
Then,
Multiply.
yeah, remember that 2/3 means, even though it's a fraction, it means division.
Yeah, you do. See.
And now what should I do with the negative 2? Because we're dealing with all fractions now, I should also do a 1.
You should put it over 1.
So now I need to put it over 1. So to me, I think this is a lot of extra steps here. Now we need to put what here?
3 over 2.
3 over 2. Now we need to reduce each side. Either multiply now and reduce later, or reduce now. Which way do you want to do it? Reduce now or reduce later?
Reduce now.
Reduce now.
Well, I'd be 1 and 1.
Yeah.
Well,
1 and 1. Now what's 3 times negative 1?
3. Negative 3.
And then 2
0.
and 2? Not 0 though.
Maybe 1. They'd be each 1.
Yep, they'd each be 1. Now we got to reduce again. 3 and 3.
1.
1 again. What's 1 times x just divided by 1? 1x or
That's the goal,
x.
right? When you get x by itself.
Okay. So either way, you get the same answer.
So either way it works. If you see what in the problem, if you see one fraction, all right, like in this problem, there's only one fraction. You can multiply everything in the problem by the number on the bottom. That's what Mr. Hager was showing you before. You can multiply every number in the problem by the number on the bottom of the fraction. Or you can do it this way, like we did the beginning of the year. Right? If you want to use Mr. Hager's shortcut, you can do that. If you want to do it this way, where we get x by itself, you use the reciprocal and do it that way, that works too. It's entirely up to you how you want to do it.
Now this problem is going to be harder if you didn't use the shortcut. Because if you have a fraction here, you would say, well, my first step would be to add 5/3. Well, that's going to be a pain, because now I have to do 8 plus 5/3. I have to find common denominators. Versus if I just triple everything, now I can solve that a lot faster. Okay? Just by tripling each thing. Right? But it's up to you. If you have fractions and you want to deal with reciprocals and like terms, go ahead.
Hey guys, tomorrow when we do our little review, we'll make sure we do another one like that. Alright, now we're going to actually graph a linear function. Now, what's one way? Yeah, we can take out a ruler and we can draw a straight line, right? But what's one format that we use to graph lines? Does anybody remember? We haven't done a lot with it yet so far this year, but anybody have done something with it in middle school? What's that format you usually use to graph a line? Anybody remember? We talked about actually at the beginning of the lesson today. Y equals mx plus b. You may know how to do that. You may know where to start, you may know where to go, you may know how to make your line. But we're not there yet. Right? We're not at that point yet. That's going to be chapter 4 stuff. That's stuff we'll do when we come back from Thanksgiving break. We haven't done that yet. So we're going to graph a function, but we're going to use a table. Alright? Kind of like we did last week when we had like the word problems. We made the table, we plugged in, we came up with the x values, we plugged them in, we got y, then we got our coordinate. Alright? We're doing something similar to that with this. Alright? So we're going to pick 5 different x values to use in creating our table. Now, you don't have to do any type of math to come up with those what those numbers are going to be. Those numbers, when we do a problem like this, those numbers are going to be the same every time. You're always going to use these numbers when you're doing something like this. Alright? So we're going to pick 5 different x values to use in creating our table. And like I just said, you're not going to have to add or subtract, multiply, reciprocal. You're not going to do any of that. You're going to know what the numbers are. Because the reason being, we're going to tell you right now what those numbers are going to be. Alright? So, the values we're going to use are, we always use the values -2, -1, 0, 1, 2. Right? -2, -1, 0, 1, and 2. Now, why? Can someone tell me by raising their hand. Why do you think we want to use those values? Well,
Because they're easier to use numbers.
yeah, they're not all even, but
They're easier.
why are they easier?
Because they're short.
Yeah, they're small, right? They're small numbers. We don't have -100 or they're not big numbers. They're relatively small. But we have a good mix. We have a couple negatives, right? We got a couple positives. We got 0 in there. We got a good mix, right? They're numbers that we can work with. And when we multiply, chances are we're going to know how to do that multiplication probably without using a calculator. All right? So we're always using these values. On a test, any practice we do tonight, practice we do tomorrow, test on Thursday, plug in these numbers. We do something like this. Because we're not at the point of using y equals mx plus b. We're not there yet. You may know how to, but we haven't shown you yet. When we show you how to do it, we want you to use y equals mx plus b. But not for this. We're not there yet. Alright? There's our chart. Now, on the test, you may not have this. You may have to write it yourself. On the reference sheet, you may not have this. Look back at your notes tonight. Alright? When we ask you to graph, you have to use the chart. Doesn't have to be perfect with lines going across. It can just be something generic like, here's your x, line, the thing here. Right? You can just make it very, very simple. It doesn't have to be super, super neat. Alright? Here it is. Numbers are already filled in. But for you guys, the numbers might not be filled in. You have to know. When you're doing a graph, there's the numbers you want to use. Now, that this shows you what the chart's going to look like. We haven't given you the function yet. This is just what the chart's going to look like. Alright? Now, example 3. F of x equals -2x plus 5. Somebody tell me by raising their hand, what are the x values going to be? Mallory.
-2.
Yep.
-1.
Yep.
0. 1 and 2.
There you go. Every time we use this. Now, it says, f of x equals, right? What do you think we're going to put here? Someone tell me by raising their hand. What do you think I'm going to put there? Now, don't worry about filling this in yet, filling in the whole column. Just worry about that top. What do you think we're going to put, Will?
Would you have to put negative 2x plus 5?
Yeah, we're going to put the actual function in this box. All I'm doing is writing the function in there. Negative 2x plus 5. That's the function. We'll use that every time in this column. All right. Someone tell me what I'm going to write in this first box. Joe?
Would it be f?
We don't have to write f of x every time. Let's just write the function.
So it'd be negative 2
Yeah.
times negative 2
Excellent.
plus 5.
Yeah. So what'd you do, Joe?
What?
What'd you do?
So you would add negative. Well,
I'm just saying. What did you do? What did you do here? Explain to me what you did.
I replaced the x with a negative.
Yeah. You just took the number that was here, right, for the x value, and plugged it in for x. That's all we're doing. Taking the number that's here for x and plugging it in for x in the actual function. All right. Now, sorry, Miss David. What happened here? All right. Now, next one. I'm not going to solve yet. If it were me, I'd go through and set them all up first. That way I'm not making a mistake plugging stuff in.
That's
Right?
what I'm doing.
So I think he skipped that.
What
Yeah.
happened?
He skipped that.
Oh, okay. Sorry. Guys, go back to that on the bottom where it says next and lastly. Plug in each x value into the formula you were given to find f of x. So that's basically what Joe just told us. Joe took that negative 2 and he plugged it in. Right? Took the negative 2 and he plugged it in to the function. That's the first thing you want to do. Because when you do that, you're going to get this column. When you do the math in this box, you'll get the answer in this box. When you do the math in this box, you'll get the answer in this box. Alright? Because remember, what does f of x, what is f of x? F of x is a fancy way of saying what? What does it mean? I know it means f of x, but how it also means what?
Function of x.
Function of x, but it also means y, right? It also means y equals. We're just changing it. Right? F of x means y equals. Again, there's two ways. We're doing function notation. Alright? Sometimes we do like, usually we do like slope intercept. But for this, we use f of x because it's function notation. But it means the same thing as y equals. F of x equals same thing as y equals. It means the same exact thing. Right? It's just written a different way. Alright? And then lastly, I'll take everything from this column. That'll be my x values. I'll take everything from this column. That'll be my f of x or my y's. Like I said, f of x means the same thing as y. Alright? So we go back here. In my next box. So Joe told me my first box. How am I going to fill in my next box? Nathan, what do you think? Look how we filled in this first box. It was negative 2, and I plugged in negative 2. What's my next one going to be?
The same thing about negative 1 we plugged in.
Exactly. So it'll be negative 2, negative 1, plus 5. How about, Ginny? This next one. So we just had negative 2 times negative 1 plus 5. What about this box? Yep. Yep. Excellent. Z, this box.
Negative 2, 1,
Yep.
plus 5.
Excellent. And how about Jack, this last box?
Negative 2, 2, plus 5.
Excellent. Negative 2 times a positive 2 plus 5. So they're all filled in. Now, I'm just going to do the math in my head, on a piece of paper, on the calculator. I don't care. It doesn't matter, as long as you get it. Alright? So I got a negative 2 and a negative 2. Alright, I'm multiplying them. What do I get? 4 plus 5?
9.
9. Alright? 9's going to go there.
Oh, wait, it is? Oh, I thought you were supposed to put the equation there.
What happened?
4 plus 5, 2 plus 5.
I thought it was good. All right. This one, -2, -2, -1 multiplying. Huh? +2.
7.
2. Good, we got 7 here. Down here.
It degrades, it goes
Negative
down by 2s.
Yeah, no one already noticed the pennies. Like, Mr. Roy, I'm just going to stop. I'm going to see. I know this next one is going to be 5,
3.
1. Again, right, it's going with decreasing by 2 each time. All right? Because it is a function, right? Now, all I'm doing here is taking this column, putting it here. Taking this column, putting it here. So what's my first coordinate going to be?
-2.
So all Mr. Hager did was he just took the first ones and brought them over. So all we did, guys, is that makes, I know Mr. Hager just kind of moves some stuff around. He's a magician over there. But all we did was all the x's from here, we just wrote right there. All the y's, or the f of x, we took and put right there. There's our coordinates. Now, what is our graph going to look like? Is it going to be like a swoop? What's it going to look like, Gemini? It's going to be a straight line, right? How do we know that based on what we learned last week? It's a function, but what kind of a function? Linear, right? Because we're increasing by 1 each time, the same value, and we're decreasing by 2 each time. So we know it's going to be a straight line based on what we learned last week. All right, cool. Now, does anybody feel like they're not really sure how to graph? Not really sure, Josiah? Huh? Okay. So let's go through this. Remember, -2's over here. All right, remember, this is my x-axis. This is my y-axis. You don't have a graph on there? On the bottom, Joe.
I'm sorry.
That's for example 3, though.
This is example 3.
Wait,
It's okay. I know, guys. The box on the top was just to show you what the actual. But listen. Time out. Everybody relax. Whoa. If you wrote it in there, it's okay. Just cross out the other one.
Alright.
Easy fix. You guys are rowdy proud today. Fired up.
It's been a long
Everyone's getting that hankering for turkey. They want their turkey on Thursday.
Alright,
We'll get there. We're gonna get there, everybody. We'll get there. I promise. I want mine too.
Lamb's better.
We'll get there.
Whoa.
I'm gonna throw something.
Go down to T's
Yeah.
office.
All right. So x and y, right? -2. I'm gonna go over left 2, up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So Josiah, that's -2,9. -1, 7. Am I going left or am I going right? Am I going left or right?
Stay to the.
I'm going left, and then what?
Up 9.
Up how many?
7.
7. 1, 2, 3, 4, 5, 6, 7. There it is. All right. 0, 5. Right in the middle, up 5. Mr. Hager's putting it. 1, 3. Am I on the right or am I on the left?
Right.
I'm on the right, then up 3, then 2, 1. And like we talked about, there's our straight line. We knew based on last week that's a linear function. Again, but we're not going to ask you guys to say, is it a linear function? Is it non-linear? All you need to know is what the numbers you have to plug in. -2, -1, 0, 1, 2. Those numbers are the same every single time we do this. Those are the numbers that you use. Don't try to come up with your own numbers. Those are the ones we want you to use. All right? So I got one more page of notes to give you. Yeah, just one more example.
Is that it?
Yeah, that's it. So now, all right, here we go. So the function c of x equals 1750x minus 10 represents the cost in dollars of buying X tickets to a concert with a $10 coupon.
Dude, yeah.
So let me ask you this. On here, all right? Looking at this function, how much is it per ticket? $17.50, right? So regardless of how many tickets you buy, how much are you getting off? $10. You're not getting $10 off each ticket.
You get $10 off the total.
The total, very good. Hey man, I'll make the rules.
That's messed.
Sorry. All right, so it's saying that X represents the amount of tickets.
Yeah.
So it wants us to set up a function and I want to know the total cost when you buy 5 tickets. And we said X, you guys just told me, X represents number of tickets. X represents number of tickets. What's C of X going to represent? Anybody know? If X represents the number of tickets, what's C of X going to represent? Yeah, the total cost, right? So it's asking us to figure out the total cost. So in our problem, what letters should we have?
X.
C of X should be together, because that's the total cost. That's what we're trying to find. So C of X equals, what am I going to put now? Someone tell me by raising their hand. What am I going to put now?
17.5.
17.5.
Minus 10.
I got this one.
I got 17.5. Now X represents what?
The number.
Number of tickets. Are we given a number of tickets?
No.
How many, Madison? 5, right?
Yes, we are.
What is the total cost when you buy 5 tickets?
So for one.
5, all right, minus the 10. That's it set up. Anybody have any questions on how we got that?
Wait, do we have to solve it?
I took the 5, because I know X represents number of tickets. It's telling me I'm buying 5. Total cost is C of X. That's what I'm trying to find. So I got to do 1750 times 5. Mr. Hager's going to do that for us.
175 minus 10 equals 160. But
$87.5.
your number values.
Yeah, 87.5.
So 8750. And Noah's quick with that math. I forgot. 8750, right? Equals, I'm writing everything else down. C of X minus 10.
I finally have my multiplication.
8750 minus 10.
77.50.
7750. Good math.
Shenanigans.
So that's how much it's going to cost to buy 5 tickets.
That's retarded.
7750. Did you get the $10 off at the end? What? You good? Fred, you okay? Hey, give me that look at the store. Where'd you get that from? Alright, you're good. Again, it told us 5 tickets. It said in the problem, X represents number of tickets. Just plug it in. Now, we're going to do the opposite. We're going to do the opposite this time. We're going to give you total cost, alright, and we want to find how many tickets we can buy with that amount.
You can buy 8.
Alright, so, how many can you buy at 130 bucks? What are we plugging 130 in for this time?
The cost.
The
The cost. What's represented by cost? C of X. Very good. So I'm going to start with 130
Yeah.
equals, after the equal sign, what am I going to have? 1750
38. X minus 10.
minus 10. Now, this is when it gets a little trickier. Remember, when you're plugging in for X, usually what you're going to have to do is multiply, and then add or subtract, depending on what the sign is. When we're plugging in for Y, it becomes like an equation, when we have to do it on opposite sides. No, what do you want to do first?
Oh, that's not what I was doing, but I was doing the total.
Okay.
Yeah, the total. I was
Someone tell me what I'm going to do first here.
Oh, you do
Valerie?
C of
Are you
X.
gonna add 10?
Add 10. I want to get X by itself. Add 10. Add 10. 130 plus 10? 140.
I got
Equals 17. That cancels out. Last step. Nathan, what am I going to do? Agreed. By what number? 17.5. 17.5. X
I got 8.
equals.
Open the door.
Alright, Mr. Oh, sorry, Mr. Hager. My bad.
I got 8.
You got 8? Okay.
Yeah, I got 8.
So I got 140 divided by 17.5.
So it's 140 and then minus 10.
I can't hear you over my digits.
That's it. So with $130, you can buy 8 tickets. Good, Savannah? Yes?
Yeah.
You sure?
Yeah, I got it.
Alright, you're still rocking that spidget, spidget.
Fidget spinner.
Good, can I move on?
No.
You can't see
I
me
swear to
with
God,
my
those are the same days.
Can I go? Yes, no? Okay.
No one can see me with my fidget.
Here's the deal, listen up. So I'm gonna give you guys still got a little bit of time, so you gotta print off your reference sheet. Listen very carefully, spidget that. Spidget. Half day tomorrow, there's the periods. We have you during period 3 time. Class is gonna be from 9:17 to 9:56 tomorrow. You're gonna get the reference sheet. Alright, reference sheet is on Google Classroom. Do it tonight. We'll go over it in class tomorrow. We'll also have some practice problems to do after we review. Alright? Half day Wednesday. Wednesday's when we'll have the test. We'll have a good 55 minutes to be able to do the test. 6 questions.
Noah, you were too late. Actually, you
Move right
can
now.
see my fidget spinner. Noah, I don't know.